Hello, welcome back. It's our first time meeting on this channel for all the SHS students. Those preparing for the Wassce today, we have a special gift for you. What a special gift. Now, there's this topic that challenged most of you, and we are going to break it down for you to understand this thing to the core. All the tricks and tips involved in these circle theorems. A topic that I know that enhance most of SHS students. The minute they see it, they don't want to even tackle the question. They don't want to even read. But I'm telling you, I'm challenging you today that when you listen to this video, when you listen to this and apply the principles that I'm going to teach you here, then you will be able to what? To answer these and become a master of the circle theorem. If I hope you understand what I'm saying here. Yeah. So those of you who don't understand the circle theorem, make sure you listen well. And if you get this video, share it to all your friends before the paper. Let them watch it several times. So that this year we all solve the circle theorem. So let's don't waste much time. All of you should get ready for the lesson. Good. Now, this one thing I have noticed here. When it comes to circle theorem, most of the problem comes from the fact that you want to understand the thing based on a single diagram. No. For you to master circle theorem, you need to know the principles. The diagrams that are drawn for you will change, but the principles underlining the diagram does not change. I want you to get this. Most of the diagrams will change, and that's why you guys don't really get it. So here we are going to hit on the principles, draw the diagram, but teach you all that is involved. And the notes too. When you get to the note, read the notes very well, because all the tricks are also there. I hope you get the point I'm making here. So let's go straight into it. Now, when we say circle theorem, we are just looking at relationship between circles and what? And angles. So let's call it angles in what? In circles. This part 2 of what? Of angles. We have angle part 1 and we have angle part 2. So circle theorem gives us what? Part 2 of what? Of angles. I hope you get the point I'm making here. Good. Let's go straight into this. The first thing we are going to look at is what I call the chord principle. The principle underlining what? The chord. In fact, when I have a circle, what is the chord? A line that is drawn from one end of the circumference to the other is referred to as what? The chord. I hope you get the point I'm making here. I said, listen to I'll give you the principles. Forget the drawing. When you understand the principle, I will be changing the drawing, but the principles will be the same. Good. So let's go. So I'm saying that we have this chord. What's a chord? A line that is drawn from one end to the other. So I have the chord. Now, one end of the circumference to the other. Then I have a triangle on this chord. I have a triangle on this chord. Another triangle on this chord. Another triangle on this chord. This is very important to me. That means these two triangles are sharing the same chord. That's one thing you should look out for. So in the diagram, no matter how the diagram is drawn, I said the drawing of the diagram don't matter, but the principles matter. One, so if you look at this, I said, one, the triangles must share what? Must share a common chord. So this is the chord that they are sharing, two triangles on the same chord. So once they are sharing the same chord, the next thing is that they should be in the same direction. Are you listening to the principle? They should be in the same direction. Once they are in the same direction, their tips or their vertices to touch the wall, the circumference. Once it touch the circumference, then the property will work. What's the property? That the angle here is equal to what? The angle there. So that means that if here is A and that's B, then A must be equal to what? B. Let's take this thing again. Let's gradually take this and understand. I'm saying that in circle theorems, the first thing I'm calling here is the chord principle. What's the chord principle? There's a chord. What's a chord? A line drawn from one side to the other, one point of the circumference to the other point of the circumference. Good. Then these are two triangles. No matter the number of triangles, forget the number of triangles. If there are 30 triangles sharing the same chord, the principle is that the triangles, plural, the triangles must share a common chord. They must be in the same direction, and they must touch what? The circumference. Their vertices must touch the circumference. And the law will work that A must be equal to what? B. If there's a third triangle, and that triangle also faces this, then B is C, then A equals B equals what? C. The angles are all equal. That is to say that if I have this other circle, and this is my chord, once again, notice my chord, and there's a triangle here, and there's a triangle here, and there's another triangle there. I want to draw another triangle here. Good. There's a triangle here and a triangle there. The principle I'm teaching you, if you look at this diagram, you understand it, but if you only follow the diagram, you won't get this. The diagram has changed. Why am I saying so? But the principle remains the same. Look at this. Look at this. Look at it very carefully. These are two triangles. From there to there are two triangles. They share a common chord. Now, they are facing the same direction, and since they are facing the same direction, their vertices are also touching this. If they don't touch, it doesn't work. So they must face the same direction. Once they face the same direction, if here is A, there is also what? There is also A. This is what I'm saying. So if you follow the principle, the diagram might change, but you will get what? You will get the same answer, or the answer will be what? The same. So forget the diagram and understand the principle. So in this principle, anytime you are given the word, you are looking for what? So in this case, if the angle here is 30 degrees, if the angle here is 30 degrees, I'm trying to find angle A. Then A straight away equals what? Equals 30 degrees. I'm done. How did I know? I checked the two triangles. They were sharing the same chord in the same direction, and they were all touching the vertex. And that gives me my what? My answer. I hope you get the point I'm making here. Good. Now let me play with this thing a little bit. Let me play with it. I just want to show you the different ways by which the diagrams will draw, but still the principle is working. Remember, they are sharing a common chord. So when I separate them, they will behave the same because they are all coming from the same chord. Good. So when I have the circle, and this time I have this triangle and that triangle, I have these two triangles sitting on this. So they are coming from, now I separate them, separate the two triangles. And I put this stroke here and that stroke here. If you understand angles part 1, you will know that the stroke means that the length are all the same. They are coming from here. They share a common chord. And since they are sharing the common chord, then the angle here A is the same triangle. So this also will be that. So in this case, once again, A equals what? Equals B. What are we saying? They share the same word. They are sharing the same chord. They have a common chord. They are facing the same direction, and that happens. So I'm just playing with this. So I took this guy, separate them, and I still have that. Now this same guy, this is what I want to do. I want to move them from the center and from the circumference and force them to the center. That means there will be another diagram that will look this way. I'll have this one here, that one there, that one there. Once again, they share a common chord. This I'm playing with. When I'm playing, I force this guy, all them, push them to the center. When I push them to the center, this is A once again. That is what? B. So once again, this and this are what? Equal. So I'm just playing with the first one. But the most important thing is what I've said earlier, that for you to get this, then what do? We look at the fact that do they have a common chord? It's all in the notes. You have a common chord. The triangles must have the same direction, must be in the same direction. And the triangles must start the circumference or the center. So they are all touching the center, or they are all going to the circumference, and that makes sense. So we have this, and it makes sense. Now the last thing I want to do is to just put these guys together. So once I put in, the most important thing here you are looking at is because of the fact that they are sharing the common chord. If not that, what we are doing will not work. Good. So another circle for me. Then this time I have this. I'll hold these ends and push them together. When I push them together, I'll get something like this. I'll get something like this. This is that. That is that. I'll get A, and I'll get what? B. Very important. So when the drawings are coming, when we start solving the question, I'm going back and looking at this. Once again, it's just the first one. I've played them this way. I hope you understand what is going on. You understand this? Okay. So this is the first part, which is the chord. Anytime you have the chord, anytime you have this, look at it. So the diagram doesn't matter. Just understand the principle. Why have a chord? What are the triangles sitting on it? Are they in the same direction? Are they touching the circumference? Are they touching the center? And that works for this. I hope you get the point I'm making. So that's about the chord. Then we go to the second thing, which is the center. So we dealt with chord. We'll go to center. So the second one is what? The center. I'm teaching the principles here, so get to know. If you have any question, give me to me in the comment section, and I'm going to engage you by answering. That's what I'm saying. Good. So don't forget, as you're doing this, so you share to all the phone three, share to all of them. Once you have subscribed, share to them, share to them, share. The question, comment, and we are going to work. I'm going to answer it. Let's be quick here. So we want to deal with the center as well. The center, okay, so I have the circle. Once again, we have a common chord. So the triangles are going to share a common chord. Then we have a center here. One of the triangles at the center, and one of them at the circumference. Very, very, very important. Listen to the principles. I had a circle. There are two triangles. Unlike the first one where both of them were touching the circumference, this one is different. One of them is is at the center and the other is at the what? Circumference. If I call this A and I call that B. Are we getting the point I'm making here? This is different from this one, is the principle of the center. So when you read any question, they say, in the diagram below, or is the center, what? Then this center things or this center will work. You have to now focus on that. There's a center, then I'm looking at this. What we did earlier was not a center. So we don't even, once we don't hear that, we are fine. Like, if you don't hear, you see a dot there, that means that's the center. What I drew earlier, I didn't put any center there. Good. But the minute I have a diagram, even the question is, I see this is it, that's my center. I hope you get the point I'm making here. Very, very important. So for center, this is what we say. They share a common chord. One should be at the center and the other at the wall, at the circumference. The direction doesn't matter. The point is that one should be at the wall, at the center, and the other at the wall, circumference. And the last thing that I want to take note of, this is something secret here, is that you check the shape of their arcs. You see the way the arc is. This arc goes with the shape to be the same. And when that happens, then the law works. This says that the angle at the circumference, you multiply that angle by 2, and you get the one at the center. That means 2 times of what? Of the circumference equals the one at the center. How we get the point I'm making here? One at the circumference equals the one at the center. That means the center is very important. For you to be able to equal to the center, you need to multiply yourself by what? By 2. Hope you get the point I'm making here. Good. That will not really matter when you don't know how to figure out either the center or not. So when you say the center, what are we looking at? We are looking at the fact that, okay, this guy, there's one at the center and there's one at the circumference. 2 times the guy at the circumference equals the guy at the center. So unless you multiply this by 2, you can't get this. Once again, this diagram doesn't matter. When I draw the diagram this way, one should get to know I have my chord, then I have my what? My center. Then this is another triangle. Hope you see what is going on. So once again, this is my angle. Let me put B here and put A here. So it follows what I have there. The law will still work. Why would it work? Because I have one of the angles at the center and the other one at the wall, at the circumference. And look at the shape of the arc. I said that's the secret here. The arcs are looking that. And in that case, we say they are what? That means 2 times the one at the circumference, which is 2 times of A, should be equal to what? B. 2 times the angle at the circumference equals the angle at the center. So this will make sense. When you see the diagram in the center, go and look for the fact. Is there a triangle at the center? Is there a triangle at the circumference? After getting them, check the last secret, which is what? Which is the shape of the arc. Look at the shape of the arc or the angle. It goes this way, this way. If they go this way, they also are equal. Look at an example like that. I hope you get the point I'm making here. So it is not the drawing, but understanding of the drawing. We can also have another drawing that goes this way. I have this, and I have another one this way, center. Then I have this. So you see how different this one is looking from that. But at the end of the day, this is once again B, that is what? A. And it will still work. Why would it work? We have a common chord, one of them at the center, one at the circumference. I hope you get the point I'm making. And we want to look for the secret, that the arcs are all in the same shape. I hope you get the point I'm making. So once again, for this, 2 times of the angle at the circumference equals the angle at the center. So 2A should be equal to what? B. I hope you get the point I'm making here. I hope you understand what I'm saying. Very, very important. Very, very, very important. Now, let me show you the next thing here. Still on this. Remember that once we have the center, then any line from the center to the circumference becomes our radius. I'll use that as well. So not the drawing, but understanding. Now let's look at this and see if that will also work. The principle says that, for center says that one of them, they are sharing first of all a common chord. So I have this, we are sharing a common chord. One angle at the center, what a nice thing. One angle at the circumference, listen. One angle at the center, one angle at the circumference, so this one's qualified. Now look at the secret. So this angle here, if the angle at the center is B and the angle at the circumference is A, then once again, this two work. Why would it work? 2 times of the one at the circumference should be equal to the one at the center. So here, I didn't say that they should be in the same direction. I didn't say that. They can be in the open. Then I said this is the secret. The secret in the sense that we are looking at the shape of the wall, of the arc. This one went this way, that was like a mountain and a mountain. That one went like a valley and a valley. How we get a point I'm making here? So with this, be able to also get this. So when the diagrams are drawn for you, forget the diagram and look and listen or try to apply the principle. Do they have a chord? Yes, they're sharing a common chord. One at the center, one at the wall, at the circumference. Okay, let me look at the last thing that qualifies. Look at the shape of their wall, their arcs, and they do that. Then this second law or this second property also works. Hope you understand what I'm saying here. Good, good, good. If you have any question, go to the comment section and you give us the question. Then we reply. Okay. Now, the next thing. The next thing here is to what? Is to look at something here. Yeah. The next thing, we have this. We have this. Now, if you look at this, you see that we have this and this. This means that the center here, from here to here, is my what? Radius, and that, this is another secret here that beats most of you. This is what? This is the radius and under what? Under radius. So if that be the case, the angle here should be the same as an isosceles triangle has been formed. Since an isosceles triangle has been formed, then the angle here should be equal to the angle there. Keep that in mind. The moment you're solving the question and it tells you, or you see that there's a triangle going to the center, that triangle is isosceles. Keep that in, whether the question tells you or not. These are the basic principles of people. These are the basic principles. Whether the question tells me or not, I should know that the moment a triangle is formed at the center, that triangle is isosceles. So I know how to play it. Hope you get the point I'm making here. Good. So if what we have discussed, if I have something like this, well, what we discussed, if this time the angle here, say the angle here is 240, and I'm supposed to find angle A, we said 2 times of A should be equal to what? Should be equal to B. That means we get 2A equals what? 240 degrees. And that will be the case, then A will be equal to 240 over 2. So A will be equal to this, will cancel that. It goes here, what? 120. So we'll get what? 120 degrees. So the angle here is 120 what? Degrees. This is how it is being done. Now, let me try apply something here and let's see. I'm supposed to find the angle here A. When these angles are given, this side is given as well, as let's say 40 degrees. So only this side was given as 40 degrees. I'm supposed to go and find the angle A here. I'll change the principle. What principle will work here? Let me draw the question properly for you to see what I'm talking about. I hope you can see. I hope you can see that. Good. So let's continue so we don't waste much time. Now you can see that, like I said earlier, the moment the triangle is formed here, we have an isosceles triangle. So if here is 40, automatically this side also becomes what? 40 degrees. Then I place a variable here B because I know the connection. That since they are sharing the same chord, the angle at the center and the circumference are connected. How are they connected? 2 times of the guy at the circumference equals the guy at the what? The center. So my question is, once I know the guy at the center, I can get the guy at the what? The circumference. But how would I know that? I was given only one angle as 40. That's no problem. I understand that the triangle which is starting at the center is isosceles. So if there's 40, there's also what? 40. Therefore, I'm going to say that we'll look at more questions and we'll go deep into the understand. This equals what? Equals 180. Some of angles in the triangle. If that be the case, that will give me 80 plus B equals what? Equals 180. I'll get B equals 180 minus 80. Then B should be equal to what? B equals 100 degrees. B equals 100 degrees. I don't need B. The question is going to find what? A. I know that 2 times of A equals what? B. But we know this. So therefore, we'll get 2A equals 100. So A will be equal to 100 over 2. Then A equals what? 50 degrees. I hope you understand what I'm saying. I want to feel the principle. Then I take questions and go deep into them. Solve all for you. You understand? Once again, go into the principles with what? With you. I hope you get the point I'm making here. Very, very, very important to me and to you. Because like I've said earlier on, most people miss what? The principle. And when they miss the principle, they don't get what is going on. So as I'm saying this, keep the principles and not what? Really the diagrams. Note all the secrets I'm giving you and apply them so that you can solve your what? Circle theorems. Okay, the next one we'll deal with is the diameter. The third thing is what? The diameter. So we have done 2. We've done the chord. We've done the what? The center. We're looking at the diameter. Now, the diameter is a special chord, people. Just that it passes through what? The center. It also goes from one end to the other, but it will pass through the center. So the diameter times we call the special chord. Any triangle subtended on the diameter gives 90 degrees. Take note of this. Most people used to forget this guy. That's why the question become difficult. It's not difficult though. It's not difficult. I'm proving to you that it's not difficult. And I dare you to listen and practice. And you see how easy these things can be. Good. So when we have a diameter, any triangle sitting on the diameter, no matter which side of the circumference is touching, once on the diameter, you have 90. So therefore, if I have this, and this is my center, and I have this, any triangle that sits this way, if you are sitting this way, once you're on the diameter, then you are giving what? You are giving an angle of 90 degrees. Take note of that. So the diameter is very simple in the sense that for diameter, the angle is subtends. Or the triangle that sits on it will subtend, will hold an angle of 90 at the circumference. When I put another one here, another guy here, this guy also gives what? 90 degrees. So 90 plus 90 will give us what? Give us 180. How the diameter becomes? The diameter is very simple. Very, very simple. In the question, you will not have the center. Sometimes they don't give the center, but they will tell you that BD is the diameter. Okay, if BD is the diameter, then straight away I can move on. Hope you get the point I'm making here. Good. But once again, when you read a question, they will not tell you that this is the diameter. When you read it, they say, O is the center, or the center. O is the center. Any line that goes to the center is the diameter. So if it's a triangle sitting on that line, then that triangle must hold an angle of what? 90 degrees. I don't know if you get the point I'm making here. So the question always tells you should understand what the diameter is. Is the line passing to the center? Do I see a triangle on it? No matter the size of the triangle, once it is touching the circumference, it's what? It's 90 degrees. Good. So that's about the diameter. And that leads us to something called the cyclic quadrilaterals. Cyclic what? Quadrilaterals. Now, for cyclic quadrilateral, this is a cyclic quadrilateral in the sense that this is a four-sided figure. 1, 2, 3, 4. And all the sides are touching the circle. That is what we call what? Cyclic quadrilaterals. And that is what we are going to look at. The next thing we are looking at is what? Is the fourth one. And that is what? The cyclic quadrilaterals. Cyclic quadrilaterals. Cyclic quadrilaterals. So for cyclic quadrilateral, this is what we have. I have this circle, and this thing, most of the time, if you don't take care, you will not even notice that it is part of your calculation. And you will sit on the question, you don't know what to do. So take note, open your eyes when it comes to this. If I have this one to be A, and that one is what? C, and this is B, and that is D. I just want to make sure I'm using the angles in the notes so I get it right. Now, opposite angles will sum up to what? 180. What does that mean? That means that now, so if you look at this trick I gave you here, I said here the angles, all the holes is 90 here. All the verts of the quadrilateral should touch the circumference. That's how it works. All this. If one of them is not touched, it's not working. So all of them must touch in order for us to apply this principle. And the principle states that A plus B should be equal to what? 180, and C plus B should also be equal to what? 180. This is the property of this is the what? The quadrilateral or the cyclic what? Quadrilateral. The opposite sides sum up to what? 180, or opposite angles are supplementary, not complementary, they are supplementary. I hope you get the point I'm making here. Yes, very, very, very important. These are the aligning secrets and these things in what? In circle theory. I hope you get the point. I hope you understand it. I just want to make sure that you get what I'm saying. Because when we start solving the question, these things look very easy. I'm going to make the questions we solve also easy. So in this, you have to sit down, get the concept, so that in the next video, we can also now take questions and break them down. Then you are fine with this. I hope you get the point. So here we are learning all the principles, plus little questions that we're solving something small. But when we resume, when we come to the next video, we're going to solve questions upon questions. Then you get to know how to play it. So go back and, like I said, go and learn all those principles that we discussed earlier on in this video, and be fine. Now, this is one of the aspects that most people also don't get, and that's the tangent. Very simple. That's the tangent. And that's the last principle we are looking at. We're looking at the fifth one, which I'm calling, or which is the tangent. Now, the tangent is a line that touches the circumference, that passes past by the circumference. So this is it. If I draw a line this way, it touches the circumference, then that line becomes a tangent. And a tangent will divide into three parts. We'll call the A. That is, this time we look at a tangent and the radius. So we're looking at tangent and radius. Now, if we have a radius, what's a radius? A line that is drawn from the center to the circumference of the what? Of the circle. The angle between the tangent and the radius is 90 degrees. That's one thing you should know. the angle, the tangent and the radius are perpendicular. That means they form an angle of what? 90 degrees. Keep this. So we are dividing the tangent into this. This one's easy. This is the third aspect of the tangent that most of you get confused. So listen to the trick I'm coming to give you here for you to get it. I've also tried to explain it in common language in the note, but I'll still say it here for you to understand. So if you don't get it in the note, the reading, you should also look at the video here and understand it. Okay. So now we have this. And this one is the second part. So this one is the radius, the tangent and the radius. Very simple. Once the radius means the tangent, it gives a 90 degree. Then we go to the tangent and the diameter. And the diameter, same as the radius. If I have this, which is mass, this should be the center, at least, okay. Then I have this line touching this. Then this one also gives more 90 degrees. Very important. So for tangent, we have the radius and we have what? This. And the other one which I'm interested in, the C part, is the tangent and the triangle. The triangle. And most people get confused. So open your eyes and look at this very well. Now we have this. Look at this. Then I have this tangent here. I have this tangent here. Touch it. Then I have this triangle drawn attached to this guy. This triangle is drawn attached to this guy. Remember, there is an angle between this guy and that guy. There's an angle here as well. Good. Very important. Let me label all it before I do now. There's an angle here. Now, look at this. What is happening here? Look at this. I've given the principles here. Now, the angle between the tangent and the triangle, the angle between the tangent and the triangle is equal to the angle subtended by the sides of the triangle. The arcs do not touch. Look at what I'm trying to look at. This theater is confused, but look at it very carefully. I'm saying that the angle here A will be equal to the angle here. I hope you get the point. I'm equal to what? The angle here. So that if this is A, this is A. You see the arc is touching this side. So the angle cannot be here, the angle cannot be there to be the other side. That's what I meant by this is the trick. The trick is very simple. I have this angle here, and this angle's arc is touching this line. It is not equal to any angle on this line. So any angle on this line is not the answer. It goes to an angle that is not connected to this. That means the angle here will be what? Will be A. I hope you get a point. Listen to this carefully. I said this times in the drawing, I've singled them out. So it looks that, but in the drawing to look a bit that. So listen very carefully. Once again, let's go. I said the angle between the tangent and the triangle is equal to the angle from, or the angle from whose lines are not touched by the arcs of the angle we're looking at. What do I mean? So this guy touches this. So therefore, the angle cannot be on this because your arc touches that line. So the angle will not be here, to not be there, but to be there. Once again, this guy is touching this line. So if angle here is B, this guy, look at the angle, the arc is touching this line. Hence, an angle cannot be here, cannot be there, but it will be what? It will be here. Because this line, this arc is not touching this. Still makes a little bit sense. Oh, you don't get it. Yeah, it makes sense. So what I'm trying to say here is that the last thing, then we end for today. Then we now come back and look at all the calculations to this. Look at all the calculations. Go deep into it. Then you understand. All that I've said, I'll use them to solve the question for you to understand. I don't want to put so very short. Just sit down today, understand the principles. And when we start solving the questions, you get what is going on very, very well. From all the principles we look at, from principle 1 to what? To 5. And the 5 is talking about the tangent. So let me go over this again. I'm saying here that for this one, I draw this one to this. For this one, move from here to here. And since it has touched this line, the angle goes not to this, not to that, but to this. I hope you understand what I'm saying here. Very, very important. So these are the principles involved in the circle theorem. When we start solving the questions, people, we are going to look at how to use all this. We're going to go and refer you back to this. So I want you to sit down and watch this one. When I start solving the questions with you, any question, you should be able to get it. I'll apply all. So what have we looked at so far? Look at the chord. We said for the chord, they should share a common chord. Then once they share the common chord, they should all move in the same direction. They should start the circumference. That is the thing. So we don't care what the diagram is. Are they sharing the same chord? Yes, they do. Are they in the same direction? Yes, they are. Are they touching the circumference? Then we see the angles are all equal. The second thing we said is that, good, once these are sharing the same chord, the one at the center, one at the wall, the circumference. 2 times the guy at the circumference equals the guy at the center. We multiply the guy at the circumference by what? By 2. We'll get the guy at the center. And this is what happens. The secret that I gave you was that the axis must be what? Must be the same direction or same shape. One of them will go in the valley form, now go in the mountain. I demonstrated that. When you go back, you see what that is. But then we came to the diameter, where we said for the diameter, we have a straight line that goes through any triangle that sits on the diameter will hold an angle of what? 90 degrees. How we get a point? Then we look at the cyclic. For cyclic quadrilateral, we said that the 4 sides of the quadrilateral must touch what? The circle. Once it touches the circle, then they are what? The opposite angles are what? Are supplementary. Then we came to who? This is my last guy, this is my guy, this is my guy. This is what confused most of you. But when I solve the question, you understand. Now, the last guy is the tangent. So we said tangent can go with radius, very simple. The radius touches this and forms an angle of 90. You will need it in solving some of the questions. So if a question is given to me this way, automatically I can know this is 90 to help me do something. So I just need to understand that the diameter subtending or joining the tangent gives me what? 90 degrees. Then my favorite one, which says that the triangle we have here, the angle between the tangent and the wall and the triangle is always equal to the guy far from it, in the sense that its arc does not touch this side. So the line or the side of the triangle where the arc touches cannot form the angle, but the angle is formed at the other side. People, thank you very much for watching this to the end. Make sure you have shared, you have commented, and you have subscribed. Because it's very important, like I said earlier on, share it to all your friends. Let them know that this one will help them to understand it better. In our next video, we are going to solve more questions for you to get this. Thank you very much for joining this class.